Hello, my name is Omar Perez,
And my name is Angelise. And
and
together
together
we
we are
are
the
the
Physio
Physio Friends.
Friends. We are a collaborative team working to make physiology concepts easier to understand. I serve as the conceptual director and primary editor.
I serve as the illustrator and artistic director.
Today we will be explaining the function of the endocrine system. To understand the importance of the endocrine system, we must first understand the purpose it serves. The body has two primary forms of communication within itself: the nervous system and the endocrine system. The body chooses either of these systems to relay messages from one part of the body to another. But the goal of the message is where the body chooses the nervous system versus the endocrine system. Let me explain this further. If the body wants to relay a message quickly to one cell or a small group of cells, then it will choose the nervous system. This is done by a neuron directly sending a message to the area it wants to communicate with via action potentials. This could be like me sending a text message directly to Angelique saying, "Don't you love physiology so much?" And she replies back,
OMG, Dr. Predator's my favorite.
if the body wants to communicate to a large quantity of cells in different areas, it wouldn't send many action potentials to different spots. Instead, it sends out messenger signals called hormones into the blood to reach all different parts of the body. This is how the endocrine system works. So let's say I want to let all my friends know that they should take physiology with Dr. Predmore. Instead of sending 1,000+ texts, I would just create a social media post stating this. It may take a little longer to reach all of my friends, but now I reach a larger group with less overall effort.
So, how does this apply to the body?
Well, I'm glad you asked. What is your favorite breakfast food?
Oh, I absolutely love pancakes.
Perfect. Well, pancakes are a high carbohydrate food, and when it gets digested, it turns into many molecules of glucose. Your body will absorb this glucose in the blood for use by the cells. This is where the endocrine system comes into play. Cells within the pancreas help control the movement of nutrients within the body. If we zoom into an area of the pancreas called the islets of Langerhans, we can see two special cells called the alpha and beta cells. These two cells coincide with each other to maintain this balance. When blood sugar is elevated, beta cells release the hormone insulin. Insulin serves to promote the absorption of nutrients into the cells, such as carbs, fats, and proteins. There are four main triggers that cause the release of insulin into the blood. The first is high blood glucose, which can happen after consuming carbohydrates like pancakes. The second reason is after consuming a high protein meal, like the classic Tom and Jerry steak. The third reason is reacting to the parasympathetic nervous system. This portion of the autonomic nervous system tells the body to rest and digest. For example, after Doug the Pug ate his birthday cake, he had to rest on the couch and digest the food. His parasympathetic nervous system tells his pancreas to release insulin to be able to absorb the glucose from the cake. The fourth reason is in response to GI hormones, such as the small intestine releasing the hormone secretin.
Wow, interesting. So, is insulin working all the time in the body? What happens if you haven't eaten anything in a while? Does your blood sugar just bottom out?
That's a good question. Fortunately, the endocrine system is all about finding a good balance. If you haven't eaten for a while, the level of glucose will deplete to a certain level, but will then find a stable point that it can stay at. This function is controlled by the antagonist of insulin, glucagon.
Glucagon? Kind of sounds like glucose gone.
Good observation. In the absence of incoming glucose, the alpha cells release glucagon, which stimulates the release of nutrients out of the cell and into the blood. Glucagon is released by three main stimuli, the first being low blood glucose levels. The second is the sympathetic nervous system activating the fight or flight response.
Why would we want high levels of blood sugar during fight or flight?
Good question. So imagine it's Black Friday and there's only one TV left. The TV might as well be a block of chum in shark infested water. Only one person is going to get the TV, and the body knows this. The body releases glucagon so that blood sugar can rise up and spark an energy boost to trigger enough strength and speed to be the winner of the TV feeding frenzy.
Ah, makes sense.
The third reason is response to high levels of blood protein.
Wait, wouldn't we want insulin so that we can absorb the protein into the cells?
Yes, that is true. However, the absorption of protein requires the use of glucose, so we want higher blood sugar to increase the amount of protein we take into the cells.
Okay, I'm really starting to understand how this works. But here's a question for you. Why don't we go through phases of high energy and low energy? How do we keep consistent levels?
Great question. So, to understand this, you need to see how this works at the cellular level. As you see here, the state of the cell works in an equilibrium. When insulin is present, the cell turns its sugars into glycogen, its fats into triglycerides, and its amino acids into proteins. This serves to provide energy storage for later, and this is why we don't get constant energy spikes. In the presence of glucagon, the cell will break down glycogen into glucose, triglycerides into fatty acids, and proteins into amino acids. This is why we don't get major energy depletions. These hormones don't just regulate the level of nutrients in the cell, but the state that they are in inside of the cell.
Great, now I really got this. So the endocrine system is basically about maintaining a balance within the body. Are there cases in which the endocrine system can fail, though?
Yes, there is. In fact, there is a specific example we can use in relation to this exact model. Diabetes mellitus occurs when the blood glucose levels are abnormally high due to failed insulin processing, and there are two types. In type 1, the immune system attacks beta cells, which causes the total absence of insulin in the body. In type 2, the body loses insulin receptors on the cell. This concept is known as insulin resistance. Basically, after long periods of time in which insulin is constantly bombarding the cells downregulate the insulin receptors on its cell surface. This leads to high blood glucose because there is less cellular machinery to get the glucose inside of the cell. This occurs in response to environmental factors such as high sugar diets.
Wow, the endocrine system is so fascinating. I'm really glad we took the time to take a deep dive into it.
Agreed. I had a great time looking deeper into the endocrine system. Well, I'm Omar Perez,
And I'm Angeles Contreras,
and
and
thank
thank
you
you
for
for watching
watching
this
this
segment
segment
of
of
Physio
Physio
Friends.
Friends.